Hello, this is Module 21, which is Community Succession. So basically, what we're looking at is communities that are moving in and taking over either a disturbed area or taking over an area that has never had any kind of um, organisms before. So ecological succession is basically just a predictable replacement of a group. So it could be because of a disturbance, like I said, or it could be just because it's new soil or new island or something along those lines. All right, so there's two types. There's primary succession, which is basically new land. So here we can see the rocks are breaking down and it forms a variety of things. So lichens are further breaking down the rocks. And then we get soil, a little bit of soil forming. And then you get wildflowers, perennials, shrubs onto trees. So primary succession means that there was no soil in the first place. So it's basically like new land. So this could be an island, it could be new soil forming after a volcanic eruption. It could be just the fact that parent rock, the bedrock, is breaking down into soil and it's able to hold plants and animals afterwards. So, primary would be nothing was there to begin with. And then the second is secondary succession. And so, secondary succession is that there was a disturbance. So, there's something happened, like, for example, the car fire. That's a great example. So, there's an area where there was lots of greenery or some greenery, and a fire blew through. And then now things are starting to come back. And so, you can see that firsthand around here. You can see that, some of the land was completely scorched, but then we've had the last couple of years a crazy abundance of wildflowers. So I've never seen so many wildflowers before in this area. And last year they seemed to go on forever. It was months and months and months of wildflowers, which was really awesome. But then you're starting to see some of the toyon bushes come back, some of the manzanita coming back. A lot of the oak trees that are highly adapted to fires are coming back. Their whole trunks and canopy were burned, but at the bottom from the roots, they're growing back in kind of like a bush-like form, and then they'll eventually be trees again. And so that's secondary succession. So there was already living things here and they're coming back after that disturbance. So that's the main difference. Time wise, it's about the same. In order for soil to form, if you're thinking about primary succession, you have to the soil formation takes quite a few years. But then once you have the soil, then this succession is about the same as each other. All right, so you can also get succession in aquatic ecosystems. So what happens here is you've got this lake here, and then over time it fills in. There's sediment that accumulates, and eventually it fills all the way in. We're talking, hundreds and hundreds of years. So then the lake fills in, and this is also we're talking about a Mary Lake type lake. So not like the Great Lakes or anything that big. And then eventually it fills in, and then you've got this kind of marsh like swampy area. There are some vernal pools that are very similar to this in fields where you'll see that they hold a little bit of water in the spring, but then they are completely dry in the summer. That is very similar to this. And so this can happen in lakes as well. So succession in aquatic systems as well. All right, so if we look at the richness of a species or a community, it's influenced by these four things. So we've got latitude, which is how far up away from the equator you are. And then time, how much time has there been? Habitat size. So what was is the island large? Is it small? Is the area that something lives in large or small? And then is it far away from other communities? So is it close and can they intermingle with other communities, or is it really far away? And so taking into consideration all these things, we have come up with a theory of island biogeography. And so basically, it just shows how important habitat size is and distance from a main area that determines the species richness. So, if we look at the island area, so this is the size of the island. So 0 would be obviously pretty small. And then moving up to 200 hectares. So you can see the number of bird species. So they did this study in Hungary, and they noticed that the bigger the island, the larger the diversity of species of bird. which makes sense. There's more habitat, there's more area for them to be. And so it's going to be more diverse. If it's a small habitat, then it's a small diversity. So this can apply to islands, but this can also apply to inland islands. So what I mean is an area, let's say that we've kind of enclosed an area off because we've built human habitat all the way around it. And so that could be, in a sense, an island. And if it's a small island, then or small area, then you're going to have a very small diversity. If you have a large island, a large area for animals, then you'll have a larger diversity. So when we're thinking about humans developing, it's really important to have interconnectedness. So we talked a little bit last time about the land bridges. So that's really important because if we isolate organisms in these little inland islands, then they are not going to be very diverse and it's going to be a very unhealthy ecosystem. But if they're able to intermingle with other communities, then now we have a diverse area, even though humans are interspersed throughout that. So this island theory goes both with actual islands and with isolated communities because of development. All right, so I want you guys to think about this question. What does this video have to do with the theory of island biogeography? So this really goes along with what we talked about with the corridors, and the organism, the mule deer in this case, being able to migrate 200 miles, which is pretty crazy. Every year they do that. So without those corridors, those areas that they partitioned off for them to be able to migrate, they would have been totally isolated. And if they can't get to their breeding grounds, having a successful breeding year is not going to be very likely. And so it's pretty amazing how, one, how far they travel, but also by understanding this, by studying environmental science, people can understand, what needs to be done for those land bridges, land migrations. If they hadn't done that, then those could have isolated, humans could have isolated these little areas of deer, and it could have been similar to what we talked about with the island biogeography. So we could have isolated these little areas of deer, and then that maybe could have caused inbreeding or things like that. So definitely really important to understand. Hopefully, we'll get time this year to do I have a short little lab that goes with the island of biogeography, which you guys will understand. The smaller, so the bigger island is going to have the most diversity, right? Because it's the biggest. And then the smaller islands, the further away you get from the mainland, the smaller and smaller diversity it gets, because one, organisms have to travel like this deer, but they also, it's a smaller and smaller area. So just think about it, and then we will do a little activity about it. But hope you enjoyed, and I'll see you next time.